We will balance the wheels with the road force test on the Hunter machine. It's a bit old machine, but still reliable and still showing nice things. And what we can start with, instead of using just standard accessory like you just compress the wheel from outside to lock the wheel, we'll use the quick plate. And of course you need to choose the path, the pitch for your screws, so it sits really nice in the screw holes. So I checked this before, and instead of using standard cone, we'll use expansion sleeve. So it's on the shaft, and when you screw it from outside the wheel, it's compressing, so it's giving you better fitting from inside. Let me just show you right now this. So of course I cleaned the wheel before. It's very important to have clean this surface and also this one here. So there are 3 different diameters, of course, that you can have, and when you press the wheel from outside on the shaft, it will compress and lock nicely on the diameter. And you can't do it this with just standard cone. Standard cone will only lock on the edge of the chamfer, so it's not so accurate. So yeah, let's right now put the wheel on the machine. So yeah, as I showed you just a few seconds ago, we have our sleeve, we have our wheel, our click plate, and then the nut from outside. So let's do it. Yep. Of course the pressure is checked, so you need to ensure that you have proper pressure on the wheel. This quick plate from outside, good and tight. Yes, and lock it. Now we just need to go to balance, and we need to set dimension. So dimensions are in, and we are interested in the road force test. Okay, and let's see. And we are very interested in this 70 newtons, it's the limit. Everything above this, we should try to optimize this. So we are testing first wheel. I'll try maybe to show you how it looks like. So the shafts lock on the wheel, there's around 700 kilograms. And he's measuring the wood force. And you can see we are very on the limit, but let's see if the machine will show us that we can reduce this force a bit. Yeah. Yes, detect. And now we can test the runout. So what I will do, I will take the arms, inner arm and outside arm, and we will see the runout of the rim from inside. And also here, of course, they're not super accurate, like you will take the tire off. But when you have complete wheel, it's just easier for you to troubleshoot. So we select runout matching. You could do it without tire, just bare rim. But we will do, of course, with the rim, with the tire, which is much easier. We put 2 arms here, and let's see. So what we deal with, we deal with the exceeded limit for the tire. So we have a result from the matching. So the rim passed the diagnostic. What didn't pass the diagnostic is the tire. And the system shows us that we can try rotate the tire. So I should mark it here and then rotate tire with the rim 90 degree, but we will do it, of course. And we can see how much we can decrease. For now, it's above the limit 70 newtons. If we click show what force he expects to have after matching, it's 65 newtons, 15 newtons less. Could be good, right? We can also see the details. Okay, runout matching, show before, yes, and now we can show the details. So here we have the results. The outer runout of the rim was 0.4 and here 0.25 from inside. So the rim passed the inspection. What didn't pass inspection is the tire itself. And of course we can have plots here. So when I rotate with the rim, you can see all details that you need. But of course, if you're not so nerdy, you don't need to evaluate this so much. You can hide the tire, show the tire, so you can see that the tire gives the biggest issue, not the rim itself. You can see assembly together, so tire and the rim. Good. Yes, let's not focus on this. Let's just exit. I'll right now mark the tires, and I'll mark it from outside, because when I'll be rotating the tire, I'll just see only marks from outside. So let me mark it here. All right. And then we need to mark the tire here. And I just need to find something what is good. Yeah, we can take this one. So you can use this tape. It's very light, and that will be enough. Yes, 12 o'clock. Good. So let's just do it right now. So I marked the rim as well and the tire. So the goal is to rotate the tire to the position marked on the rim. And let's see if Hunter is right. And we'll gain 15 newtons. So around 1.5 kilo in feeling of road force on the road. So let's us take the wheel. Top. We'll need some loop. Yes. Oh, too much of loop. Okay. We'll use it soon. So we need to watch out for the valve. Please be careful with it. Okay. here. Okay. Now on the other side. Okay. And be careful for the valve. All right. Just check here. Oh. Yeah, that's not good. Just need to correct it. Much better, much better, much better. Okay. Good, and now from the bottom. From the bottom will be a bit harder to make it properly. Yes. Okie dokie. Now we can try to rotate tire to this position. Sometimes it's very hard to do it. Opa. Up. So we have it, what is recommended by the machine. Now we need to give the correct pressure. In this case it's 3.1. Now we will need, yes, valve. We're using torque wrench. It is dedicated especially for the valves. And now we can check the proper pressure that should be in the car. In this case it's 3.1. Yep, good. It's good. Yes. And I like always to bounce a bit the wheel. I have seen this many years ago when the guy in the tire shop was doing this, and I believe it's better do it than not. besides this machine anyway will lock this shaft 700 kilo on the wheel, so I'm not worried. Yes. Okay, and now we can check if we succeed. Balance. Yes, so the wheel is back after rotation, and you can see the tire is marked on the same level like the rim, like my machine proposed. And now we can go back to the test again. And you can see that it's pressing bits to sit down on the rims. Yeah, 65 inside the limit. Perfect. I'm happy with the result. 15 newtons, it's always something, right? So now it's time to put the counterweights on the rim. And for doing this, we need to clean the surface so the glue will stick really nice to the rim. I just use normal benzene, nothing fancy. Yes, we need 10 grams, and I already have, so I don't need to cut. Some people use here just knife and cut here. I just prefer with the scissors. And I can see, yeah, let's try. I can put 10 grams right now. On this side. I'm not. Yes, so I put the counterweights 10 gram as machine proposed, from inside only, from outside nothing. And now we don't need to check any more force, road force, so I will just put it back, so it only will check balance. Okay. So now we can go to another wheel. And just for my selection in the future, I'll just write here 65 newtons, because I'm very picky. If you talk about vibrations, I don't want to feel it in the car at all. So I will choose the wheels which has the lowest force to be in the front of the car. So, yes. So next one. And you can see cleaned, pressure 3.1, and we can put in the machine. Yes. Actually, the dimensions should be the same, but I always like to do it one more time. So set dimension. Go here from outside and then from inside. Yes, we have measurements. And of course we'd like to have with the road force, and we need to change here. Road force, press OK. So now it's time for second wheel. We are checking. Try to find for you something nice. can see 70, again on the limit. Grams of counterweights. Yes, and we'll do runout matching. And now I need my hands. So now again we are taking the arms inside, outside, press start. Measurement done, and let's see what we have here. So again, rim is inside, tire again outside. It shows right now 70 newtons, so it's perfectly on the I would say on the limit, because everything outside of the 70 newtons should be improved. And how much it promises after optimization? Only 10 newtons. It's not much, but always something, right? Always something. But you know, always you should ask yourself, you should find if you should fight with the 10 newtons. What I'll do right now, I'll just put it on site and then decide later if I should do it. Let us check two last wheels, because if they'll be really good, then of course I can just spend time and rotate the tire. No problem with that. I'll just mark it. Yeah, I can see it's not even 90 degree. It's like 45 degree. To be honest, no, I'll just not spend time on it. I'll just mark it if I will decide. Let me find, yes, 12 o'clock. 12. And then the rim. Here. Here is the rim. So you can see it's 45 degree. Okay, let's mark it and see later. And I'll just mark. My fancy folia. Here, yes. Yep. Good. But for now, let's just put it on site. Yep. So you can wait here for decision. Second last. So the wheel number 3 is on. We can use the same dimensions, doesn't matter really. Road force. Okay. perfect. I like this wheel. This wheel will go to the front. Only 30 newtons and the limit 70. So 30 newtons, around 3 kilograms, and only 15 outside. Perfect. This is what we want to see. And then these wheels should go to the front axle. So now let's clean with the benzene. Yes, nice and clean. Take 15 grams. And we put it here. Yep, we take the shaft to roll it here. Nice. So the 15 grams is placed. We don't need force again, so we'll just take it off. And we just need to confirm balancing right now. Okay. And I'll mark for myself 30. What's happening here? 30 newtons. Because then I will know that it should go to the front. Last one, I hope it will be also nice one. Oppa. Good. Road force test. The last wheel is waiting. Road force test, yes. Okay. .30 newtons, perfect. Yes, great. Now it's time to put the counterweights. $20 grams. Already have it here. I like this. Yep. 20. Go there. Now shafty. 20 grams on the place where they should to be. And now we can check without force. That's balancing. Great. So now, since we have 3 wheels already done, I'll just try to reduce the 70 newtons down. And let's see. And I'll just write again. 30 newtons. Yes, so it will go to front. So we have selected two fronts. This is the rear, because it was here how much? 65 newtons. Okay, so let's try to rip off that one. And maybe we should do experiment. Instead of rotating this 45 degree, let's try rotate this 180 degree, and then let's see what will be the result. What do you think? Because gaining 2 newtons, it's not so, exciting. Check. We can grease the tire. Now the rim here. And now we can take the bottom. Just not so easy here. Not so easy. Especially that always wants to go off. And then let's just do experiment. Instead of just rotating this 45 degree, let's take 180 degree and let's see what results we'll have. Oh, it's always hard to do it, so it's like free gym. Sometimes it's just easier to take the tire off and do it. Now it goes. Almost there. Yep. Yes, you can see right now here the mark, right? we rotate the tire 180 degree. Let's see. Machine didn't ask for it, so let's see the result. Okay, that's enough. Yeah, I forgot to use my proper tool. This one. Good and tight. And now correct pressure, 3.1 bar in this case, for this car and this tire size. 3.1. Yep. And then a bit bouncing. Yep. And on the machine. So we are doing here experiment. Machine asked to match this one with this, but I was like more curious, and for the movie I decided to put it opposite, so 180 degree, and see what the result will be. So yes, we want road force. Okay, close the hood, and let's see. Oh, we did worst. From 70 newtons we went to 110. So maybe it's better to listen. Maybe it's better to listen. Machine. Let's see right now what it will propose. I need my hands. So now we need to measure again. Sebastian wanted to be smart as, and didn't work. So you can see that I wanted to be smart and move our mark 180 degree, but machine is smarter than me, and it shows that if I'll listen to her, I'll reduce it to 70 newtons like in the beginning. Let's see when he wants to place it. So that's the rim mark. And it's almost like he showed last time. There's small difference. And then he wants me to take the tire from new point, from here. So, but the last one was there. Okay, now we have small differences. Let's try. I'll just use different color. Like here with yellow. here we have the first mark, and first mark on the tire. That was the original from the last season, and it was 80 newtons. And that one was on the valve. So if you bring this one here, more or less will go back how was the old position. Let's try it. Oh, come on, go out. Go out from the field. Watch out for the valve. Now it's easier because it's just fresh. So that's the second mark, and that was the first one. So let's try to see if I put the second one to relieve the beats. That was the second mark. We're almost close to the old position. The first proposal was this one. So let's just take what was the proposed for the first time. This mark with this. Because the second mark was somewhere here. So we just need to be right now more to trust the process. It's so hard to rotate it. Little bit more. A little more. Yes, almost there. Almost there. So we have right now first mark, first proposal. And before was this with the valve. Okay. Okay, and now proper wrench for the valves. Listen this. Yes, that's the proper way. I always have tendency to put more than I should, and that's why I need to use tools like this to not have issue afterwards. Okay, 3.1, yes. And now let's check the result. A few bounces. Yep. So we are taking right now this back. So you can see I just rotate the tire to the first proposal from the machine, and the old position was valve and original mark from the factory of the tire. So now let's just listen to the machine and let's see. Balance. Close on the lid. I just choose the wrong one. It will just check runout of the whole wheel instead of force. But I want to see the force. Yes, I just need to change road force test. Okay. Let's run. What? What? 10 newtons? Okay, interesting. But he promised me to have only 70. Okay, just to make sure that everything is fine, I'll right now rotate the wheel, keep the shaft standing in this position and rotate the wheel 180 degrees, just to make sure that we don't have any here wrong measurement. So just to confirm, unscrew, keep the shaft. I will need to find, okay, some orientation valve. I'm keeping the shaft and rotating the wheel 180 degrees. And now locking again. Yep, tightening up. And now let's double check. So I rotate the wheel on shaft. I kept shaft hold. And again, wrong settings. You want road force test. Okay, road force. Okay, 5 is close to 10 and 10 is close to 5. That's very good to see. And then imbalance 15. Let me just put the counterweights on the wheel. Yes. Let's clean it. 15. Yep. 15 on the place. And now we will just check the balance itself. Okay, okay. And now again, because I like to check things a few times, especially when it's about balancing. I will loosen up the nut, keep the shaft here, and again take this valve 180 degree, lock it up. I want to see it one more time. Okay, okay, good. So we had 5 and 10 newtons. I'll just mark 10. 10 newtons. So actually this could go to front. I just need to measure afterwards the height of the threads. So we have 2 times 30 newtons. This is 10, and that stayed on 65. 65. Shall we try to do something with the 65? Let's check one more time with few positions. I just want to see. Maybe we could reduce it a bit. Not sure. Let's try. Let's test one more time this one with 65. And we'll check in 2 positions. So first position on the shaft, and then rotate the wheel and keep the shaft on the same position. Okay, so close to each other, 85, 70. Okay, we'll test 2 things right now. We'll find proposal from machine how to rotate the tire in correlation with the rim. And then I'll rotate the wheel and keep the shaft standing, so we have rotated on machine 180 degree. So arms, but we have counterweights, but only here. Okay, so this side I didn't look. That's nice. Then I don't need to take it off. It's enough like this. So what's the proposition here? After nothing changed, 85, no proposition, so it doesn't make sense to do it, right? You can see that the mark stays on the same position, so no. But what I will do right now, I'll just rotate the wheel on machine 180 degree to see how good we are with the measuring the same values. So I'm loosening up the nut. Yep, keep the shaft in the same position, trying to find valve, like just orientation point, and 180 degree and lock it. Opa. So now we'll rotate it on the shaft. Let's go to balance. Yes, road force test. Foot down. Okay. And let's drive. 80, so we are the same. 80 here, 80 there. Now just balancing result. And we are good with balancing, so now in this wheel I can't do more. That's what I can do. So this wheel must go to the rear axle. On the rear. So we have these two 30 newtons, and this one was 10 actually. That was a really big difference after rotation. So sometimes machine doesn't show you, you know, real situation, but of course it's the best is to measure on the bare rim. Maybe I'll just find quickly some rim and I'll just show you how to measure this on this machine. So yeah, I can actually put this 3 on the front. Probably this 3 I'll go to the front and this and that one to the back. Of course, first I just need to measure the height of the threads. Here I'll just show you how to measure bare rim, so rim itself standing with that tire. First, let's put it. Yep. Our old quick plates. Now on the market, of course, you can buy much fresh equipment, but since I don't do it this professionally, then doesn't make a big difference for me. I run out matchmaking. A match without rim run out, but I can measure bare rim. And now what it will change, you can see that now I need to take first this one and press. Okay. And it's measuring run out from the inside. Yes, and now I need to change to the outside. Yes. And you have the result. So you can see here details, and you can see it's perfectly in. Let me see the details. So the maximum what was measured from inner was 0.26 millimeter, which is really good. It's for the performance car. 0.2 millimeter, it's really good result. I can maybe later find some data sheet and share with you to show you, but this rim is really good. And this rim is from BMW 5 Series G30. I forgot to show you that you can see the plot and you can see how it is measured and rotate with the rim, and you can change the results because here's the inner rim radial and you can change to outer. Of course, outer is reinforced with the arms, so if something should be bended, it's usually in the inner, right? And let's show inner and radial. And you can see here on the top we have something maybe dirty, but no, I don't feel under the finger. It would be nice to clean, of course, before measurement, but it was just to quick show you what are the options here in this machine. So yes, thank you very much for today. If I helped and you're happy with this small video, just leave a like and subscribe. Thank you.